So we're going to go through the dilution process one more time. So in a dilution, you should know the starting concentration that you have. So you're being told here that you have a stock solution of KMnO4, and the concentration is 0.01 moles per dm cubed. So since that's your original or starting concentration, we called this value C1 for our dilution equation. We then have assigned values or decided upon values, which are the final concentration and volume of what we want to make, and that's C2 and V2. So from an equation standpoint, if we're comfortable using the dilution equation, we've got C1V1 equals C2V2. Really the only thing that we're missing now is the volume. What we're trying to find out is how much of this original solution here, how much of that do we need to measure out to make the final solution with the final concentration and the volume. So let's walk through that. We can get V1 by itself by dividing both sides of that equation by C1. We get C2 V2 over C1. If we plug in, we get 1 times 10 to the minus 4, and we have 0.5 for our dm cubed, and on the bottom we have C1, which was 0.01. Okay, now if we do this math out, we should get 0.005 dm cubed, which is 5 cm cubed. Okay, so let's walk through what that means. It means that we need to measure out 5 milliliters, 5 centimeters cubed, of this original solution up here, this more concentrated one. And then what we're going to do, because our final volume is 500, that means we would take the 5 centimeters cubed, we would measure this out with a pipette, a nice, precise, accurate pipette. Then we're going to add that to our volumetric flask, and then we're going to add more or less 495 centimeters cubed of water. And between the 5 centimeters cubed of the original solution and the 495 centimeters cubed of water, we're going to end up at our 500 centimeters cubed total volume. So that's how it ties in with that original volume amount. This is the assigned volume amount. So the equation solves for how much of the original concentrated solution you need, and then you need to work out the amount of water that you need to add to get to the final target volume, or volume 2. So that's how you can use the equation. This tells you how much of the original you need. And with the equation, if you want to double check, they should both equal each other. What you're basically saying is that the moles before and after are equal. So you can ignore these instructions right now. That because in dilution, all we're doing is adding water. So we're not changing the moles that are dissolved in the solution. We're just spreading them out a lot more by adding a lot more water and making it much less concentrated. So if you plug in your C1 and V1 value, it should equal your C2 and your V2 value. The moles should be the same. And so using the values in this question, 0.01 times 0.005 is the same as 1 times 10 to the minus 4 times 0.5. So one of them is higher in concentration but much smaller in volume, and this one is lower in concentration but much higher in volume by the same factor. Okay? The second way to think through this question, or to double check that you've done the calculation right, if you compare the original solution, we'll do it in a different color. The original concentration is 0.01, which is the same as 1 times 10 to the minus 2 mole per dm cubed. And so the other way to approach this question is to say, well, from the starting concentration to the ending concentration, which is here, the assigned value, that concentration is decreasing, and I can tell it goes from 10 to the minus 2 to 10 to the minus 4. That's a change of 10 to the second, or a change of 100. So the concentration is getting 100 times more dilute, or it's being divided by 100. Now, from this equation and what we talked about in class, this is an inverse relationship, which means that if our concentration is being divided by 100, the volume must be getting multiplied by 100. So they always change in opposite directions by the same factor. Okay, well, what times 100 is 500? The answer to that question, of course, is 5. So that tells us that if we take 5 centimeters cubed of our original solution, we need to end up at a volume that's 100 times bigger than that, and then we will have properly diluted the concentration down by a factor of 100. We will have increased the volume by a factor of 100 from 5 to 500 by adding water, and the concentration therefore will be diluted by a factor of 100, so it will be 100 times lower. So we start with 5 of the solution, and we end at 500, and we've done that by adding water. That's the concept with dilution. It's a pretty common concept to hit up on paper 1 to give you a starting volume and concentration, and then it tells you the ending volume, and so what's the new concentration, for example, and you think about what factor has the volume been increased, and that's how much the concentration will be decreased. I hope this video has maybe cleared up a couple different approaches to the dilution question. I hope it hasn't made things worse. Let me know if you have questions.